The global shortage of semiconductors is likely to continue in the short term. But the long-term future of the industry is likely to be secure and it will continue to grow, driven by communications, data processing and automotive sectors. The contribution of more electric vehicles further may worsen the supply shortage because electric vehicles need so many semiconductors in each vehicle. The silicon used in these chips is limited in supply and takes a long time to create. As automakers scramble to make electric vehicles with longer ranges and speedier charging times, the chip industry has a message for them. That is, we are doing it completely wrong. So good morning guys, we are watching our channel and video about the future replacement of semiconductors. So stay tuned for A to Z information about semiconductor industry. In the manufacturing process of semiconductors, electronic circuits with components such as transistors are formed on the surface of a silicon crystal wafer. A thin film layer that will form around the wiring, transistors and other components is deposited on the wafer. The thin film is coated with photoresist. Semiconductor companies are urging electric vehicle makers to ditch their traditional silicon chips and embrace materials that will make cars more efficient, helping ease consumers and someday making recharges as quick as gas station fill up. But there isn't an agreement yet on which approach to use. Silicon carbide is the front runner with gallium nitride emerging as a key competitor. So what are these new materials? Well, silicon carbide, as the name suggests, is a combination of two elements, that is silicon and carbon. And it does a better job as a power converter, meaning chips using the material can move energy around with less of it getting lost along the way. The same is true of gallium nitride, which is made up of gallium and nitrogen, and like silicon carbide has a distinct edge over traditional silicon. The experts say that it could cut the charging time in half. So, choosing the right technology has especially high stakes as the auto industry undergoes its biggest transformation in more than a century. Manufacturers around the world are racing to ditch internal combustion engines and even icons of the gasoline age like Ford Motor Company's Mustang. Along the way, chips have become ever more critical to how a vehicle works, spanning everything from the powertrain to the airbags. That's become painfully apparent this year as the car makers have had to limit production and leave dealer lots empty because they can't find enough silicon. But getting automakers on board with the newer technologies is critical to raising electric vehicles to the next level. It's a big learning curve for the car makers, said by the experts. They say that a good battery, a good inverter, and a good electric motor doesn't give you a good electric car. The good news is that the Tesla company has begun embracing the electric vehicles in the first place could help this Earth's transition as well. Tesla is one of the first major adopters of silicon carbide chips, and the company has implemented the technology as a key advantage of their cars. With silicon carbide, watts of power can be crammed into the battery much more quickly, cutting charging times. And it provides for longer ranges because there is less leakage, wasted power as a car taps the energy needed to drive motors. Infineon Technologies, the biggest makers of automotive chips, expects silicon carbide to exceed more than 30% of the market in the electric vehicle power chips by 2025. Silicon carbide can bring a significant advantage, literally a 5 to 10% improvement in range. Some manufacturers are already sold on this concept. General Motors is using silicon carbide devices in their EV battery platform. The basis of all of its future electric vehicles. Toyota Motor Corporation, which pioneered hybrid vehicles with Prius, uses silicon carbide in the hydrogen-powered Toyota Mirai, and its supplier Denso Corporation has built the chips into the other vehicle lines. Even the French rival PSA Group and other companies earlier this year said that it may use silicon carbide in power inverters that will be a key to mass manufacturing a new generation of electric vehicles globally. But some companies such as General Motors are hedging their bets. They are also looking at gallium nitride for future use option. Gallium nitride is a newer entrant and it's not yet clear what role it will play. Infineon expects it to complement the other technologies, and others are positioning it as a more of a rival to silicon carbide. BMW earlier this month signed a deal to secure $250 million of such chips from GAN Systems inclusive. Gallium nitride chips can cut the time it typically takes to charge a car to 4.7% to 11.3 hours, saving 70% on energy in the process. It also could boost the vehicle's range by 5% and use fewer batteries. That's according to the startup Navitas Semiconductor, which is telling investors that gallium nitride chips will account for 16% of the power semiconductor market by 2026, up from less than 1% last year. Car makers have taken years to warm up to new technologies. So, when silicon carbide was first offered to auto manufacturers more than a decade ago, they shunned it as horribly expensive. Now the same is making its way into the premium vehicles, where cost is outweighed by the performance of its benefits. There are still some painful trade-offs. Traditional silicon-based chips are made in billions each year, and the technology's 50 years of dominance has created a massive global infrastructure to produce it. That's brought costs down. Silicon carbide wafers, the basic materials on which the new chips are built, are produced by only a few companies and in a process that's still difficult and expensive. One obstacle is the material itself, which has to be grown from seed crystals in a chemical process. There are relatively few crystals available that will produce the purity required. Any impurities can result in wafers and chips that are less efficient. In a sign of how scarce the materials are, the experts say that they are ready to pay $415 million last month for GT Advanced Technologies acquiring its supplier of silicon carbide. That deal lets it secure access to the raw material. Silicon carbide components could add an extra $200 to the cost of the vehicle, according to the estimate by the company. But boosters of the new technology say the cost will quickly be adjusted because the cars won't need as many batteries. And that speaks to the need for the car makers to put more thought into the chips they used. So, the experts say that if you want to save the cost and if you want to increase range and even if you want to do all of this optimization, you will have to put your hands to adopt these new semiconductors. So finally, are semiconductor stocks good investments? Semiconductor stocks are good long-term investments. Companies in the industry have consistently increased sales over the past year and are expected to continue to do so. Amid strong chips in demand, most semiconductor stocks have significant profit margins and low levels of debt. This data says that semiconductor stocks are good long-term investments. Thus, we have come here to the end of the video, and if you want to get such video updates, subscribe to the button and hit the notification bell for the newer updates.